Evet, değerli katılımcılar, Geoenvi projesi kapsamında yürütülecek olan eğitim seminerimize hoş geldiniz. Bu seminer aslında iş paketi 3 ve 5'in ortaklaşa olarak yürüttüğü bir çalıştayın sonucunda, daha doğrusu o çalıştayda doldurulan anketlerin neticesinde yapılıyor. Ve o ankette 9. ve 10. maddelere bu eğitim seminerine katılmak istediğini ve kendi tesisinde bu program, bu proje kapsamında üretilen yaşam döngüsü değerlendirmesi ve basitleştirilmiş parametrik model uygulamalarını kendi tesis verilerine uygulamak istediklerini belirten kişiler davet edildi. Ve bu kişileri diğer bizim İtalyan proje ortaklarımız için tekrar tanıtayım. Şu anda çeviri yapılıyordur herhalde, değil mi? Bir dakika.
Evet Özge Hanım, yapılıyor şu anda.
MTN Enerji'den Çağatay Mitil, Soyak Enerji'den Tuğba Kara, Sanko Enerji'den Aygün Güney, Enerjiyo'dan Ergün İşler, Enerji ve Tabii Kaynaklar Bakanlığı Enerji İşleri Genel Müdürlüğü'nden İlker Özata ve bizim Türkiye ulusal liderimiz, proje ortağımız Cannur Bozkurt Armoni şirketinden katılıyor. Bu eğitim seminerinde 2 tane İtalyan ortağımız bize yardımcı olmayı kabul ettiler. Teşekkür ediyoruz kendilerine. Siena Üniversitesi'nde görev yapıyorlar. CSGI biriminde. Ve isimleri Lorenzo Tosti ve Nicola Ferrara. İlk önce ilk 2 sunumu Lorenzo Tosti arkadaşımız yapacak. Ve bu kısım yaşam döngüsü değerlendirmesi üretimi, yani ve bunda kullanılan protokollerin türetilmesiyle ilgili olacak. İkinci kısımda bir ara vereceğiz. Sonra soruların ardından bir ara vereceğiz. Ondan sonra ikinci kısımda da Nicola Ferrara bize bu basitleştirilmiş, bu proje kapsamında türetilen basitleştirilmiş modeller hakkında bize bilgi verecek. Ve bunun bu proje kapsamında 6 farklı seçilmiş örnek vaka var ve örnek vakaların çoğuna Macaristan vakası ve bizim örnek çalışmamız hariç hepsinde basitleştirilmiş modeller türetildi. Bu modellerden İtalyan modele, örnek vakasına uygulanmasını gösterecek, sunacak bize. Sanırım programla ilgili de sunacağı bazı şeyler olacak. Yine bu proje kapsamında bir web tabanlı platform üretildi. Ve bu platforma katılımcılarımız kendi verilerini girerek yaşam döngüsü değerlendirmesinin basitleştirilmiş modelinin sonuçlarını görebilecekler. Bununla ilgili de detaylı bir sunum yapacak arkadaşlar size. Kendilerine teşekkür ediyoruz. Ben sözü Lorenzo Tosti'ye bırakayım. Eğer bir sorunuz olursa bu chat kanalından sorabilirsiniz. Sunumları bölmeden, hani tek parça yaparak ondan sonra sunum sonunda sorarsanız arkadaşımız da en azından sunumda kafası dağılmamış olur. Şimdiden teşekkür ediyorum. Lorenzo.
Özge Hanım.
Evet, buyurun.
Açılış konuşması mı var?
Özür dilerim, çok özür dilerim. Doğru, haklısınız. Ufuk Bey ve Niyazi Hocam konuşma yapacak, kusura bakmayın. Heyecandan direkt Lorenzo'ya verdim ama Lorenzo da cevap vermedi, umarım oradadır. İlk önce Jester'den Ufuk Şentürk, yanlış söylemiyorum değil mi? Ufuk Bey ve ardından Profesör Doktor Niyazi Aksoy 9 Eylül Üniversitesi'nden bir açılış konuşması yapacak. Onun arkasından da arkadaşlarımız sunumlarını yapacaklar. Buyurun Ufuk Bey.
Selamlar herkese. Değerli sektör paydaşlarımız, hepiniz hoş geldiniz. Bugün burada malumunuz bir paydaş olarak yer aldığımız Jester olarak ve yaklaşık 18 aydır sürdürdüğümüz Geoenvi projemizin basamaklarından biri olan LCA diye uluslararası literatürde bahsedilen, Türkçesi yaşam döngüsü değerlendirmesinin durumunu paylaşmak ve yaşam döngüsü değerlendirmesi için nelerin yapılması gerektiğini öğrenmek için bir kurs amacıyla buradayız. LCA yani yaşam döngüsü değerlendirmesi, herkesin hakim olduğu üzere herhangi bir proseste kullanılan enerji, ham madde ve bundan dolayı oluşan atık ve emisyonların çevresel etkilerini ve bu süreçte doğal kaynakların tüketimini ve çevresel iyileştirme fırsatlarının değerlendirilmesi olarak kısaca bahsedebiliriz. Genel tanımıyla jeotermal enerji özelinde ele alırsak bu konuyu, jeotermal santrallerden kaynaklanan ses etkileri, termal etkiler, görüntü etkileri, fiziksel etkiler ve kimyasal etkiler gibi çevreye zarar vermesi olası etkileri en aza indirgemeyi veya ortadan kaldırmayı hedefliyor bu program. Tabii bu hedefleri gerçekleştirmek uzun zaman alan eylemleri kapsıyor ve büyük ölçüde de değişebilir olduğunu öngörmekteyiz. Bu kapsamda çevresel etkileri en aza indirgemenin yollarını bu eğitimde görecek ve santrallerimizde uygulamamız istenecek. Proje ve LCA konusundaki detaylı bilgileri İtalyan paydaşlarımız Niyazi Hocam'dan sonra sizlere aktaracaklar. Biz bu tip projelerin sektörün dünya genelinde gelişimine katkı sağlayacağına inanıyoruz ve çeşitli ülkelerdeki paydaşlarımızla ortak hareket ederek Avrupa'da bir standart yakalamayı amaçlıyoruz. Ve bilgi birikimlerimizden de faydalanarak santrallerin çevresel etkilerini minimuma indirgemeye çalışıyoruz. Bir sektör, bu sektörün global anlamda iletişimde olabileceği, bilgi paylaşımında bulunabileceği destekçi iş ortaklarının olmasının nedenle önemli olduğunun farkındayız. Böylece eksikliklerimizi tamamlıyor ve tecrübelerimizde paylaşma imkanı buluyoruz. Eğitimde belirtilecek, fakat ben yine de bir tekrarlamak istiyorum sizlere. Proje çerçevesinde jeotermal enerjinin çevresel ayak izini belirlemeye yönelik bir parametrik model geliştirildi bu proje kapsamında. Gelinen aşamada bu modelin test edilmesi gerekiyor. Bu nedenle işletmedeki tesislerimizden çevresel ayak izinin hesaplanmasını yapacak ve yapmaya niyetli olan üyelerimizi bugün bir araya getirdik. Amaca yönelik bir toplantı gerçekleştiriyoruz. Sizleri de geçtiğimiz ayda yapılan Geoenvi anketinin ilgili sorularına vermiş olduğunuz cevaplardan dolayı buradan bu nedenle sizleri davet ettik. Bugün alacağınız eğitim sonrasında sizlerden uygulamaya yönelik çeşitli taleplerimiz olacak. Ve bir o kadar da sizlerin ihtiyacı olan bilgileri bu eğitim aracılığıyla sağlamış olacağız. Bu kapsamda eğitimde alınan bilgilerin uygulanması hem proje açısından hem de sektörümüz açısından önem arz ediyor. Bu çerçevede ben sözü daha fazla uzatmadan katılımlarınız için her birinize ayrı ayrı teşekkür ve şükranlarımı sunuyorum. Verimli bir eğitim olmasını diliyorum. Saygılarımla. Niyazi Hocam buyurun. Sesiniz. Tamam.
Evet, çok teşekkür ederim. Geoenvi projesi Avrupa Birliği projesi olarak başladı. Temel amacı jeotermal enerjinin Avrupa'da daha yaygın kullanımının önündeki çevresel endişeleri ortadan kaldırmak, çevresel risk ve etkileri belirlemek üzerine kuruldu ve bunun için bir uzman olmayanların da kullanabileceği bir parametrik model geliştirilmesi bu projenin amaçlarından biriydi. Bugünkü toplantımız bu amaca yönelik. Geliştirilmiş olan parametrik modelin test edilmesi için ülkemizdeki saygın enerji kuruluşlarından birkaç firmayı davet ettik. Onlara da çok teşekkür ederiz, kabul ettiler. Ve bu eğitimden sonra gerekli çalışmaları yapacaklar. Bu çalışmaları sırasında biz projenin bu kısmını yürüten ekip olarak Özge Hanım'la ben kendilerine destek olmaya devam edeceğiz ve bu çalışmaları yapıp bu parametrik modelin ne kadar çalışıp çalışmadığını test etmiş olacağız. Ve umuyorum ki jeotermal enerji ülkemizde de çok ciddi çevresel endişelere neden oldu ve birçok projenin durması noktasına getirdi. Bu büyük, geçtiğimiz yıllardaki büyük gelişmeye rağmen yanında çok büyük çevresel sorunları da taşıdı ve çok büyük tepkiler var bildiğiniz gibi. Birçok projemiz bu yüzden ciddi sıkıntılar yaşıyor. Bu proje ve bunun çıktıları sayesinde halkımıza, çevremize ve bu işle ilgilenen her kesime bir cevap verebiliriz. Onların endişelerini giderebiliriz. Ben de bu noktada kısa kesmek istiyorum ve sözü eğitimin başlatmak için Özge Hocam'a veriyorum. Özge Lorenzo ile devam edeceğiz galiba. Çok teşekkür ederim.
Evet, sessize almışım kendimi. Teşekkür ediyoruz Ufuk Bey, Niyazi Hocam. Şimdi sunumlara geçelim. Lorenzo herhalde ekran başında sunumunu
Yeah.
yapacak. Hı hı.
Yes, I'm here. Thank you. I'll start by sharing my screen and just tell me if you can see it.
Evet, görüyoruz. Hı hı.
Okay. I think I'll put this like here. Okay. Okay. Can you see my screen and can you hear me?
Evet, hem duyuyoruz hem görüyoruz.
Thank you. Okay, thank you, thank you. Well, I'll start just with a really brief introduction of myself. My name is Lorenzo Tosti, and I am a postdoc researcher at the Center for Colloids and Surface Science. It's a university consortium, and actually I'm doing my research at the University of Siena. My background is on chemistry, but I specialized during the years in the life cycle assessment, and I'm currently working full-time at Geoenvi, and I have actively participated to the life cycle assessment guidelines development and writing of deliverables. You can find all the information and deliverables online in the Geoenvi website. I will put the link at the end of the presentation. My presentation is divided in two sections. The first one, in the first one, I will introduce the guidelines, the reason why we need the guidelines, and how these were development covering the main aspects, let's say. The second part will be dedicated to the application of the guidelines to the Turkish case study of DORA 2. And I will also show some, let's say, interactive aspects, so how you can use basically the software to perform a life cycle assessment. So let's start with part one. So as you know, and as all the energy producing processes are subject to environmental impact, they have an environmental impact when we want to produce energy. Geothermal, of course, production has also such impacts. These impacts can be divided into acoustic, thermal, visual, physical, and chemical. So when we want to, let's say, start a geothermal project, or when we are actually running a geothermal power plant, we need to respect some, for example, limit thresholds, for example, or we need to assess the impact of the plant. In this case, the life cycle assessment recently has gained a lot of attention to indeed evaluate such environmental impact. So basically, the LCA approach starts with the raw material extraction, and it goes through all the processes, all the life cycle of the geothermal power plant, so passing from production, use phase, disposal, and eventually recycle and reuse. In this process, of course, we have some resource and energy requirements, as well as raw materials. And on the other hand, we have emissions to the different environmental compartments. The life cycle assessment is a structured methodology. It's divided into 4 phases, starting with goal and scope definition, the life cycle inventory, life cycle impact assessment, and the final interpretation of results. All these steps are standardized by the ISO standard 1400 040 series. Just let me move this so you can see. But of course, these are general standard, so they don't cover exactly all the steps to perform a life cycle assessment of a geothermal case study. So they are not specifics. And this in the years has resulted in different results when it comes to the impact of geothermal power plants. And not always these results are comparable. So the so why we need guidelines for geothermal installation? That was one of the main questions. So we wanted to offer guidance to perform a consistency, balanced, and high quality life cycle assessment of a geothermal power plant in order to enhance the credibility of the findings from LCA studies. These guidelines are the object of the guidelines, and the beneficiary are LCA practitioner, but also geothermal experts. So we had to cover both technical LCA aspects as well as more general aspects that are not that a geothermal expert might not be familiar with. The guidelines cover the entire phases of the life cycle assessment, so the inventory, the impact assessment category selection, and also how to report and show results that we obtain from a life cycle assessment study. Of course, this guideline, as I told you, is the main reason we wanted to develop this guideline is to make the LCA available to everybody and clear, the application of LCA clear. But of course, it has to be complemented also with other impact assessment method. So I would first start with a bit of methodological background, because I don't know if everyone is familiar with LCA, but basically we start from let's say graphical model of how the in this case geothermal power plant works, divided in all the main phases of the life cycle. For each phase, we basically create a model of the process that constitutes this phase, and we compile a list of input, material, and energy requirements, and a list of outputs that basically are emissions of wastes or direct emissions to air or to water. When we have created when we created the model, then basically we obtain a list of input and output. This list is multiplied by a characterization factor to obtain an impact in different categories. How does this work? Basically, the phase of the impact assessment is divided into let's say phases, steps. The first one is a mandatory steps that is divided into classification and characterization. Basically, with classification, we want to answer what does this emission contribute to. So we have our list of emission, and we know that, for example, NO3 emission contribute to eutrophication. So we have a contribution, we basically have an impact on these categories due to the emission of NO3, and so on for all the different substances. So based on the nature of the emission, we have a characterization factor that basically gives an indication on how much does this emission contribute. So for example, if we have the CO2, we know that the CO2 contributes to the climate change in terms of CO2 equivalent. This is, it equals 1. I'll get to this later. So the second two steps are basically normalization, that these are optional steps I forgot to mention. Normalization tries to answer the question, is that much? And the weighting step try to answer the question, is this important? So basically we do that by dividing the characterized impact, as you have seen before, for each category by a reference factor or normalization factor that normally comes from an average European citizen emission. So once we divide the impact, each of the impact category for a normalization factor, we goes from a different unit for each category to the same unit, and we can compare then the impact. But again, we will come, I'll show you better later in the discussion with practical example. So after this short introduction on the methodology, we goes then to the guidelines document. You can find the guidelines document online at this link. It is constituted by 30 pages, and you can see here the table of contents. As I told you, it covers basically all the main steps of life cycle assessment. And we have also 3 technical appendixes where you can find some data indication on how to allocate the different impacts from energy production, and also some other, let's say, indicators like the primary energy saving indicator to basically evaluate and compare geothermal energy production to other renewables energy production sources. So starting from the goal and scope definition, we have basically divided the types of plants into plants that produced only power, kilowatt hour of electricity, plants that produce both, power plants that produce only heating or cooling, or power plants that produce both. We have divided the system into 3 main modules: upstream module, core module, and downstream module. Our focus is, of course, on the core module, that basically it's the power plant and covers the life cycle of the power plant. So goes from the construction of the power plants with all these sub processes like construction of collection pipelines, the drilling of the well, etc. Then we have the operation and maintenance phase, where we have the eventual stimulation, the replacement of equipment, the drilling of additional wells, and wastewater treatment processes, as well, of course, as emission to air. And then the end of life, that basically covers the well abandon process, so when the wells are closed. The lifetime of the power plant is set to 30 years. As I told you, we can have plants that produce both electricity and heat. This it's called allocation, when we need to allocate, as the word says, between emission between the electricity and the heat production. When this allocation is not cannot be avoided, and we will see later when this can be avoided, but in those cases where allocation cannot be avoided, we have two let's say options to allocate co-products. One is based on system expansion, and the other one is based on exergy content. These two allocation schemes are both covered in the guidelines document. So we in Geoenvi we have covered different technological and also geographical options, let's call it case studies. And today we will focus on the Dora power plant. But as you can see, we cover different technological energy production routes, and also the size of the power plant are very different. Concerning the impact assessment method that is suggested in the guidelines, this is the environmental footprint version 3 impact assessment method. And this is in this table you can see an example of how we suggested to cover the impacts. For example, for the climate change, we give the unit of reference, we give the method that should be used, the version of the method, and these two important let's say indication on the method. So we have the level of priority. This is within the geothermal context. In this case, the climate change category is has high priority. So this means that it should always be included in a report from a life cycle assessment of a geothermal power plant. The level of robustness indicates basically how the scientific background behind the model that is used to calculate such impact. In case of climate change, the level of robustness is high, so the method is highly reliable. If you look at the human toxicity effect, this is also high priority, this category, but the level of robustness is low of the method. So we will see later on how we can deal with this aspect. So having a very important category, but a highly uncertain method to calculate such impact. Here I, in this table, reported the high priority category that are suggested in the guidelines. So you see we have climate change, of course, and we have toxicity categories, so freshwater ecotoxicity, human and human toxicity, as well as acidification, and of course mineral and fossil resource depletion. So this was a quick introduction of the guidelines, just to give you a background. And again, the guidelines is available and downloadable from Geoenvi website. I now will start with the application of this document to the real case study of DORA 2 power plant. I think I will give the floor here for the introduction of the power plant to
Yes. This is Niyazi Aksoy.
Yes.
Arkadaşlar bu proje ile alakalı olarak biz DORA 2 santralini Türkiye'de örnek olarak verdik. CSGI DORA 2 santralinin LCA'yini yaptı. Burada DORA 2'yi ben size daha önceki toplantılarda anlatmıştım. Kısaca tekrarlayacağım. DORA 2 9,5 megawattlık bir santral. Yaklaşık 10 yıldır çalışıyor. 2 üretim kuyusu, 2 reenjeksiyon kuyusuyla çalışır. Şurada gördüğünüz sınırlar içerisindeki santraldi. Geçti slide. Santralin sağında ve güneyinde 2 tesis daha var. Bunlardan biri ısıtma, diğeri karbondioksit tesisi ama bu ısıtma ve karbondioksit tesisleri bu projenin dışında. Sadece jeotermal santrale odaklanıldı. Test hakkında kısaca bilgi verecek olursak, slaytta da okuduğunuz gibi Salavatlı jeotermal sahası Menderes metamorfik masifinde Büyük Menderes grabeninde yer alıyor. Bu Türkiye'deki aşağı yukarı bütün jeotermal santrallerin ortalama koşullarına sahip. İşte sıcaklık, derinlik, karbondioksit vesaire açısından. Bu sahada ikinci geliştirilen santraldir DORA 2 ve son 15 yıl içerisinde burada yatırımcısı 5 tesis daha kurdu. 9,5 megawatt gücündedir ve bu 5 tesisten biridir. 2010 yılında devreye girdi. 2 tane üretim kuyusu var. AC3 ve AC4. Bunlar 175 derece sıcaklığa sahip. Ve derinlikleri de 1352 ve 1300 metre derinliğinde 2 üretim kuyusu. 2 tane de reenjeksiyon kuyusu var. ASR3 ve ASR4 olarak adlandırılıyor. Biri 1920 metre, diğeri 1178 metre. DORA 2 bir binary santral, ORC türünde bir santral ve 845 ton saat jeotermal akışkanla çalışıyor. Bu tesisin etrafında 2 tane tesisten söz etmiştim. Bunların yan ürünlerini kullanıyor. Fakat Geoenvi projesine onlar dahil değil. Devam edecek olursam, bu projede alınan şeyde şunlar hesaba katılmış. Water dominated, su baskın bir saha. ORC teknolojisi kullanılıyor. %1.2 NCG içeriyor. Bunun da %99'u ya da %100'ü karbondioksit sayılabilir. 9,5 megawattlık elektrik üretim kapasitesi var. 18,6 megawatt termallik bir sera ısıtma şeyi var, tesisi var. 120 bin ton saat yıllık karbondioksit tesisi var. Termal ve karbondioksit tesisi bu projenin dışında. 80 milyon kilowatt saat yılda ısı elektrik enerjisi, 30 milyon kilowatt saat ısı enerjisi üretiyor. Ömrü bunun 30 yıl tahmin ediliyor. Üretim ve enjeksiyon kuyularının sayısı 4. Toplam sondaj uzunluğu 5741 metre. Toplam boru hatlarının uzunluğu, buhar hatları dahil 3347 metre. Lorenzo, next slide, please.
Yeah.
Okay. Yeah, the floor is yours. Go on, please.
Okay, thank you. And if you need to add something, please stop me whenever you want. Okay, this is basically the let's say simplified graphic that we modeled. The goal of the study, as I already told you, in this specific case was more related to testing the LCA guidelines to a specific geothermal power plant in order to cover all the technologies that we have basically studied in the Geoenvi project. Of course, we will also show the results of such application. However, I must admit that the initial idea was really a methodological, it was more focused on the methodological approach rather than the actual results. But this being said, we selected as according to the guidelines as a functional unit, so our results will be all related to the functional unit, that is the kilowatt hour of net electricity produced over the entire life cycle, which was 30 years. As a system boundaries, we have, of course, included all material and energy requirements for constructions with related in situ emission. We have included the use phase, operational and maintenance, as well as the decommissioning. This is related basically to the well closure. In this red square, you can basically see the foreground processes. These mean that for these phases, construction, use phase, and decommissioning, we have used mainly primary data that were collected from the operator and are specific for DORA power plant. In the background processes, we made use of database. This means that all the, for example, material requirement, as an example, cement or concrete needed for the construction, the life cycle related to the production of cement was taken from a database. In a specific case, in specific case, the database used was the environmental footprint database. The environmental footprint database is part of a big project of the European Commission that is called the Environmental Footprint project. And basically within this project, they develop a very consistent database, as I showed you later in the software. And this database can be is associated to the environmental footprint impact assessment method, which is the method that we have used in these studies. What is not included in the life cycle assessment as suggested and reported in the guidelines is the electricity and heat distribution. So we stopped basically here at the production. Allocation procedure. As the professor told you, DORA can produce both electricity and heat, but in this case, since the inventory was really detailed, we were able basically to divide the all the facilities and the let's say the material requirement that were related to the electricity production with those related to heat production. So basically, as you can see, our system boundaries are set here and they exclude the heat. So everything was basically, allocation was avoided and all the impact are only due to electricity production. The data representativeness and quality is very high, I must say, for a DORA power plant. The inventory was compiled in a really detailed way, and all the main information was there. We, of course, made some assumption. The biggest one, let's say, are that the wells that are drilled during the let's say lifetime of the power plant, they will be closed after 30 years. This is of course an assumption, but as a first assumption we choose to go for this option, and also that the transport was modeled as an aggregated process. I will show you what this means, but basically this was to keep track of the transport inside the whole life cycle. So instead of putting each transport related to single material and then having a results that you cannot distinguish between the impact related to transport with the impact related to, for example, cement production, we went for the option of including transport as a single process, separated process. This is, of course, is an assumption because each material is transported in a different, from a different, let's say, truck or vehicle, but it gives us more insight on the transport weight on the final impact. I'll show you this also later. Well, this is an example of the inventory. We are now in this phase. So the inventory, as I told you, in case of DORA, was very detailed. It is important for us to basically provide the different plant operators with the same life cycle inventory, because we wanted to have a as standardized as possible format. So basically same unit of measurement, the inputs name were the same, the description, the information that we required for each plant was the same. We tried to keep it as standardized as possible in order to have basically the same data to insert in the software and then hopefully to get very comparable results. This is the database. So few really quick information, because we will go through this also in the software. The database used was the EF, so you can see different area of interest. So basically energy and transport, packaging, metals, manufacturing, chemicals, end of life. They all comes from different provider. Some of them are like Geoenvi, some other are ThinkSteps. Of course, they also development, this provider, they also develop their own database. But in this case, they were all put together and harmonized in order to be used simultaneously, with the same software. We will see later. So I will now pass to the, let's say, interactive part, let's say, of the seminar. I'll show you a bit how the software works. Well, basically, this is OpenLCA software, which is freely available for download. Once you download the software, then you have to install the database. In this case is the EF2 database, because this version is only available for as a version number 2. Here it's a basic representation of DORA 2. As you can see, basically the model is constituted by the single phase, as I told you, like DORA equipment, operation and maintenance, the commissioning, and transport separated. So basically this is a list of input and output. So we put together all these phases to obtain the final life cycle. Of course, when I expand all of them, we see that there are a lot of links with all the processes from database. But let's see more in particular how a process from database looks like. for example, here it's the electricity grid mix. So I take this process and I use it in my model. This is to show you that the level of detail of the database is very high. We have a description of the process in a fully detailed manner. In this case, it's for Italy because there is no Turkish one. We have the technology description. We have the mix, all graphical representation of what is included in basically the life cycle assessment of the electricity production. So we can really be sure of the type of process that we are using. However, when we use this type of process in our model, basically we get just a list of input and output. We are not, we don't basically keep the separation between all the let's say processes like here, like you see here, but just an aggregated list. In some other cases, you have basically, this is a transport process. You have here the same level of detail. So you can see basically the percentage of the transport, if it's urban, motorway, or rural. You have the utilization ratio, so emission per percentage of utilization. So you have a lot of the payload, you have a lot of information. And in this, in some specific case, you have also a parameterized process. Even if this comes from the database, you can still modify your value and get a corresponding basically emission. For example, in this case, you can fix, for example, you change the sulfur content of the diesel, and then you will have, of course, a different specific emission of SO2. We will see why this can be important for DORA. Well, basically, this is how the process, how a process looks like. In this case, it's the operation and maintenance. As I told you, it's just a list of input and output. If we go more in detail, we can open, for example, this is atmospheric emission. Well, here we are, our information was not filled out, but you have also, in this case, input and output. In this case, in the emission, atmospheric emission process, this is made of direct emission. But in the case of, for example, additional wells, this process is again constituted by drilling and pipelines. And if you open, it's kind of, you know, it's a kind of containers, you know, one inside each other. You can go back till the database. Like in this case, we have the pipelines, you have aluminum or steel, and if you open this one, finally you go to the database that, as I told you, is a list of input and output. Well, once we have all the process linked, we can run our model and calculate impacts. This is the method selected. Yeah, it should be fast. Yeah. And here you have your list of impact categories, as you can see here: acidification, different types of climate change, ecotoxicity, etc. Contribution from the different processes. Like in this case, we see that acidification, it's mainly influenced by diesel combustion. More in detail with the flow, the direct emission to air of nitrogen dioxide. If we want to see basically the contribution, we just go to this tab here, and we have the life cycle, different contribution from the phases. So, sorry, let me check here the acidification category. So in the acidification category, we have 65% of the impact of the whole life cycle is due to the commissioning phase. You can go inside the commissioning phase and see that the drilling contribute for more than 50%, in particular diesel emission. So this is just to give you an idea how to see the results and interpret the results. You can do this for all categories. So, well, we don't have much time to go into detail, but if I go back to the presentation, I just try to make a summary of the impacts. Of course, I divided the results in high priority categories. As you can see here, we have those high priority category. And the first thing that you can see is that except for climate change, where the direct emission of CO2 basically dominates the impact, in the other high priority categories, you have basically construction and, well, in the case of ecotoxicity, also the equipment playing the major role. In this specific case, I reported here that the copper part of the components in the equipment is contributing mostly to this category. It's very interesting to note also that the transport is playing, well, not extremely huge contribution, but still it's important, especially in the acidification and human toxicity. This is due to, as I already told you, emission of ammonia, SO2, etc., whereas the toxicity is dominated by metal emission. If we then move to the mid and low priority categories, also in this case, the construction is play almost in all cases the major role, except for well, few categories. And again, transport is quite substantial, has a quite substantial contribution in some categories, almost reaching 40%. Of course, this is a contribution to the total impact in the single category, but you don't see, as I don't know if you remember, I told you already in the beginning, well, you don't see the relative magnitude. To do that, you have to normalize. Basically, we divide the impact of the single categories for a reference value. And when we normalize, then we see that the climate change, let's say, has the biggest impact among all categories. So basically, the CO2 coming from the impact from the plant plays the major role, because the climate change, well, has the biggest impact. Well, this is a overall, let's say, picture of the power plant. We have to say that unfortunately we couldn't use the EF3 in our study because it is not yet implemented in the software. So as I told you, we use the EF2. There are few changes between using EF3 EF2 and EF3, but these are mainly related to the ecotoxicity category. So you should really be careful to when you discuss these categories, because, well, first of all, there are quite huge differences between EF2 and EF3 version, and this is mainly due to a different method, or not a different method, but an updated method that was used in EF2 and EF3. This is very detailed. I will not go into such detail. I can always answer if you want, if you have more, if you are curious. But concerning the climate change, for example, there is really no difference. So the results that you have seen here can be considered good also for the EF3. And again, we should be very careful when let's say reporting results from toxicity category to the public, because it's very let's say scaring topic. But again, we have to be really we have to understand that with LCA we are not performing a toxicological evaluation of a power plant. There is no concentration involved in LCA, but we talk only about cumulative emission during the whole life cycle. So we have a mass single value for a total mass, and that's not toxicological related impact. But it is more to say that during the whole life cycle, we might have some potential toxicity impact coming from here or from there. For example, in the case of DORA, we have seen how the transport is playing a substantial role also in the toxicity of the life cycle of DORA 2, and not only the direct emission as most of other power plants. But again, this has to be taken really, you have to be careful when saying outside these results. You should be careful and you should be aware of the level also of recommendation of the method, that, as I told you at the beginning, they are very low. So these results are very uncertain. Well, in conclusion, the whole Geoenvi, let's say, application of the guidelines, we can say that what we observed from the utilization of a common inventory file, we realized that even though we provided a common file, we did not get back the same quality and reliability data from provider. Sorry, from plant operator. This is linked, of course, to different type of installation. For example, we have a case study, a Hungarian case study is a project. It's not even running. We have pilot plants, and we had also like Bagnore. It's, well, not old, but it's running. It's very how do you say, you have a series of data, and it's a plant that is tested and it's running since the beginning of the 90s. So it's quite well, it's called old plant. So you had a different level of data quality, but also the same operator, they were let's say better than other. In this case, DORA had a very nice inventory. We were provided with a nice inventory. The database, the EF database, has less processes than traditional databases like EcoInvent. For example, there is no electricity mix for the Turkish country, but the EF database ensure a high level of completeness, and the database is completely transparent. You can download it, you can see what is behind the model, you can see everything. And in some cases, you can also change parameters, as I showed you. Unfortunately, the version 3, that is the most updated version, I'm talking about the impact assessment method now, it's not yet implemented. So you have those differences on toxicity category. Again, even though you see differences in the toxicity category, it's still the most advanced method to calculate potential impact assessment, and it should be used. Especially, I think it's going to be soon implemented in software. So we should be aware that soon it will be available, and it should be the method to be used. We have also highlight some improvement of the first version of the guidelines. In particular, we have seen how the order of priority of category should be revised. This is not the case of DORA, because DORA basically we have seen how climate change as basically should have the high priority, as it is already suggested in the guidelines. But in the Italian case, we saw that some impact categories were considered low priority, but actually when we performed the normalization, those categories were standing out compared to, for example, climate change. So we said, well, probably we should look more into those categories, like I don't know, eutrophication, instead of only climate change. Another important thing is the H2S emission. In the guidelines, we suggested to convert all the H2S to SO2 because we didn't have a characterization factor for the H2S at the beginning, because we were not considering the EF3 as method. But then we realized that the EF3 method has a characterization factor for H2S. So this emission should be entered as H2S emission. And this will be changed in the second version of the guidelines. And then, yeah, well, we are also discussing and trying to figure out the best way to communicate the results to non-LCA experts, even though the guidelines was supposed at the beginning to be let's say, a document only for LCA experts. We realized that a lot of people in the sector actually are not LCA experts. So we were trying to figure out a smart way and an easy way to communicate results. And we are thinking as an additional weighting step. So basically to have all the category like grouped into only one indicator, like one number that takes into account the impact from the category, but also the quality of the data used for the LCA, and also the reliability of the method, such as the toxicity method should be, let's say, divided for a small, for a high number, big number, because the impact in that category is very uncertain. Anyway, this is something that I can answer you if you want, but it goes quite in detail. Sorry, this last one was not translated, but this is thanks for your attention.
Teşekkür ederiz Lorenzo. Sorusu olan, sormak isteyen varsa tartışma şeyini açalım, kısmını. Buyurun. Geçen çalıştayımızda sorusu olan kişiler vardı. Bizim anlattığımız konu üzerine soruları olan. İlker Bey, bir soru sormuştunuz. Bununla alakalı mı, bu sunumla alakalı mı çok net hatırlayamıyorum ama yine LCA ile ilgili, yani yaşam döngüsü değerlendirmesiyle ilgili.
Merhabalar.
Merhabalar İlker Bey.
Aslında bugün sorularımın bir kısmının cevabını buldum. ben sadece iklim emisyonlarının yani sera gazı emisyonlarının daha öncelikli gibi olduğunu düşünmüştüm. Daha önceki sunumdan ama bugün aslında pek çok emisyon dikkate alındığını, farklı etki kategorilerinde değerlendirildiğini gördüm. Eğer hatam yoksa. O yüzden hani soruların bir kısmının cevabını aldım. Bir kısmı için de anlayıp belki ileriki konferansta veya toplantıda iletmem lazım size.
Tamam, teşekkür ederiz. Başka sorusu olan, katkı koymak isteyen var mıdır? Hocam sizin var mı? Sormak istediğiniz, değinmek istediğiniz, üstünde durmak istediğiniz.
Şu aşamada yok. Eğer başka katkı koyacak arkadaş yoksa bir ara verelim. Sonra ikinci sunuma geçelim.
Tamam. Yarım saat görünüyor programımızda. Sizce
İsterseniz daha kısa yapalım ve erken bitirmeye çalışalım. Mesela 15 dakika, şu anda saat 2:21. 3'e 20 kala, 20 dakika olsun. 3'e 20 kala tekrar bir araya gelelim derim. Ne dersiniz?
Ufuk Bey, siz ne dersiniz?
Uygundur, sıkıntı yok.
20 kala mı dedik hocam?
3'e 20 kala.
Yani 40 dakika gibi bir ara vermiş.
Hayır. Hayır.
20 dakika.
20 dakika.
20 dakika ara vermiş oluyoruz. Tercümesi bilmiyorum yapıldı mı ama Nikola, did you hear that? We will give a break for 20 minutes.
Yes.
Okay.
See you later. See you later.
See you, bye bye. Merhabalar. Eğitim seminerimizin ikinci kısmına hoş geldiniz. Bu kısımda yine Siena Üniversitesi'nden Nicola Ferrara sunumlarını yapacak. Nicola ekran başında mıdır? Nicola, do you hear me? Herhalde daha henüz gelmedi. Umarım bir yanlış anlaşılma yoktur saatlerde. Nicola. Lorenzo, sen duyuyor musun?
Yes. I just sent him a message, and he knows that it was a 20 minutes break, so I guess it's just a bit late.
I'm here. Sorry,
Yes.
sorry, I have a problem with Zoom. I didn't reach to activate again the audio. Sorry.
The floor is yours.
Okay, so just let me a little bit present myself, introduce myself. So I am a postdoc researcher from CSGI, and of course I am a partner of Geoenvi, the Geoenvi project. I am also a chemist, so my background is a chemical background, and I'm working in life cycle assessment topic during my PhD. So involved in all the 3 years of my PhD was employed in Geoenvi project. So this is my tasks at the moment. So now I will share my screen and I will show you the okay. Okay. I hope you can see here my screen. And so I will, sorry, this is the Italian one. Let's see. Okay, so these tasks are in Geoenvi are devoted to the development of simplified model for assessing the environmental performance of geothermal plants. These simplified model are devoted to simplify the life cycle assessment introduced by Lorenzo before. And so, as you have seen just a few minutes ago, it's a quite a time-consuming procedure. So the objective of such simplified models is to accelerate the process to obtain good results in terms of life cycle assessment. Indeed, such simplified models are not devoted to represent results in a life cycle assessment ISO standard in this way, because the data and of course are not completely exact, the results, since are simplified model. So there are some assumptions that make the results a little bit more imprecise, but the results, we have seen that the results are good enough to be used for first assessment of a geothermal power plant. So definitely it's a very powerful tool for decision makers and policy makers. Indeed, also for technicians that want to check very fast some environmental performance of geothermal power plant. The process to obtain we have used to obtain these simplified models is developed by Armin, so in the framework of the Geoenvi project, and this is the general procedure used to generate such model. So first of all, there are some of these steps are in common with the common life cycle assessment. So the definition of the scope of the study and the reference life cycle assessment model. So the modeling itself is very similar to the one described by Lorenzo a few minutes ago. And then there is the validation of this reference model. So this reference life cycle assessment model is used to as a model on which the simplified models are built. So this usually is a real geothermal power plant or a hypothetical geothermal power plant, and are modeled in a life cycle assessment way. And then this reference model is generalized to be able to represent also a wider set of geothermal power plant. And because of that, this reference model needs to be validated against literature or against real cases. Then this reference life cycle model is parameterized. So the model, there are some key parameters that can be identified in the model itself, and this step is essential to let this reference model be able to represent other power plant. And then after the identification of the input parameters and the assessment and the identification of the key input parameters, so just a few parameters used to that will be present in the simplified models. After this step, these simplified models are generated, and we will see one simplified model for each impact category. Definitely, these simplified models are just an equation, so just a very simple equation with some terms that are constant and some other that are variable, and this variable part are the parameters that are used as input parameters of the simplified model itself. And then after the generation, this simplified models is validated itself against the gain. As for step 2, again, against the literature or real case studies. Then the last step, very important step, is the summary and the applicability domain definition. This is very important since these simplified models are only valid in a limited range of variable and a limited range of technological, let's say, aspect of a power plant. The protocol, then from a procedure point of view, the protocol is developed in Python. I think now you can see better the screen. The protocol itself is implemented in Python using 2 libraries, which are the Brightway2 and the LC Algebraic. So the reason of this choice is that in Python it's very easy to implement a lot of novelty from a code point of view. So it's very easy from, for example, in LC Algebraic, we have a lot of functions that were let's say, developed ongoing. So when we are during the process to build these simplified models, we ask the developer of the LC Algebraic to include new functions. And so this is the reason why we choose the Python framework. And in fact, the flexibility of this tool is demonstrated by a very interesting application of these simplified models, which of course is not related to geothermal world, but indeed is wind turbine installed in Denmark. And using very few information, such as the wind speed, georeferenced the wind speed data, the location of the wind plant, so every wind turbine, the location of every wind turbine, the installed power for each wind turbine, and the sort of coefficient of productivity of each wind turbine. Using so few information, is possible to build a very interesting interactive map that I'm going to show you. This project was developed by the MinParitech, so I'm not the developer of this, of course, just showing you the very interesting output. And so, for example, in Denmark, all the power plants that are installed in Denmark, we can explore the environmental footprint of each wind turbine, so the carbon footprint, performance over time, and over different wind speed and so on. So it's a very, very interesting output. And this is just to introduce a little bit the potentiality of this tool. Now I'm trying to exit. Let's see. So there's to use this Python and the libraries, it's needed a little bit of experience in Python, in Python programming, and we choose the Anaconda package management software. In this way, we installed all the libraries needed to build this simplified model. The Brightway library is an open source framework for lifecycle assessment, which is developed by Chris Mutal, which is a researcher at the Bolshevik Institute. And it's a very interesting project which is continuously on development. So it's very supported by the community, scientific community, while the LC Algebraic is a sort of plugin for the Brightway. In fact, this LCH break can work on top of Brightway, implementing some useful function for this scope. So parameterized inventories, or for example, advanced statistical analysis and a very, very fast computation of life cycle assessment impact. And this is developed by Raphaël Jolivet, which is a researcher at the MinParisTech. So this the following part of my training seminar is talked about how we, from a practical point of view, realize these simplified models. So there are a lot of technical parts, and for example, the first things that we need to do to implement this project is to load all the libraries needed for the project. So this is Python code, and for example, we see here Brightway and LCH break. So this is the command used to load all the things that are needed to build these simplified models. And I'm running these in real time, let's say. Just a few words on Brightway. And so the Brightway is an LCA framework. It's not meant to be used as an alternative of, for example, OpenLCA, but is something that is able to introduce a lot of advanced feature for a life cycle assessment, but is the framework of Brightway is very similar to other life cycle assessment software. And so we have databases which contain the activity, the background activities and processes, and other databases, including the life cycle assessment method and so on. So it's very, from this point of view, it's very similar to other life cycle assessment software. And just to introduce you the background database we used, differently from the work introduced by Lorenzo, in this case we need to use the EcoInvent background database, since the Brightway do not include the environmental footprint database yet. So we need to use this background database. So go on, and now I'm just initializing the project. So simplified models is the name of the database and the project I'm going to build. And then I'm porting the EcoInvent 3.6 version. I already performed all of these passages before, since it's take quite a long time. So to speed up the presentation, of course, I already done it. And again, other command used to build the project I'm going to realize. So this is simplified model for the Flash category. So built on the basis of the Italian case studies, so binary 3 and 4, so the same presented by Lorenzo. And at the end, the simplified model is suitable for all Flash power plant, at least Flash power plant that fit some particular limit defined by the project itself, and that I will show you at the end of this presentation. So at the same way, the definition of the geothermal representative system, so the binary 3 and 4 power plant essentially, is very similar. Indeed, it's the same performed by Lorenzo. So we have background processes gathered by EcoInvent database, then a core module which include the construction phase, the use phase, and the decommissioning, and also including emission to air, and not including in this case the electricity and the heat distribution network. So this is to build our simplified model. now to build, in this case, we only focus on two impact category, which are the climate change impact category and the acidification potential on fresh water and terrestrial water. And this code are used to let's say memorize this impact category inside the variable, which this is the variable and this is the impact category we need. All of these are included in the Brightway, so it's possible to learn how to use Brightway just reading the documentation provided by Brightway online. So just, all of these everything reported here is open source, so you can see everything related to the library. So documentation, you can interact with the developer to ask a question and so on. So this is another key, very important point. So the open source framework of this project. So this is the command used to search for the, as you can see here, acidification category. And again, we can use this command for the climate change impact category. This this is different from the previous one because this is an specific way to use a Python command, which is called understanding list. And the comprehensive list, again, it's better. And in this way, using this logical operator, it's possible to find, search for every impact category we need. And for example, we will use the LCD 2.0 with a climate change total impact category without including the long-term characterization factor. And in fact, we can also explore some characteristic of this category. And for example, we see here the unit, which is for climate change, is the CO2 equivalent, kilogram of CO2 equivalent, and contain 196 characterization factors. These codes are needed since there are an issue connected with this particular model, and again, I'm running it in real time. Then to parameterize this reference model, we need to include parameters. And these functions are included in the LC algebraic library. And we have a lot of possible choices. For example, we can have parameters which are numerical values, and in particular float parameters. We can also use Boolean parameters, so true or false, so using this command. And also another interesting parameters which is called choice. And in this way we can, with a single parameter, we can choose a list of alternatives. And for each parameter, we can of course define everything connected with the parameter itself. So the default value and the minimum, the maximum, and also we can include a description of these parameters and the unit of measurement associated with the parameters. So because the parameters are used to describe a particular technical aspect of the model itself. So for example, we can use a parameter for the installed electrical power. So we need to describe this parameter using a minimum and maximum value. So for example, from 1 megawatt hour to megawatt electric to 20 megawatt. And so we use a parameter to describe this technical characteristic. And every parameter is also, to every parameters is also associated a probability distribution function. And for example, we can have a linear, so uniform distribution, normal distribution. Sorry, these are in Italian, I just but it's very, very self-explaining. So the uniform distribution, so every values are the 100% to be to be true. So uniform distribution, the Gaussian normal distribution, the triangular distribution, and also another kind of statistical distribution, which is called the beta distribution, which make use of two parameters, alpha and beta, to, for example, this is the shape of this probability distribution function, varying the alpha and beta parameters. But in this case, we only use the linear, so the uniform distribution, since from a computation point of view, it's much more economic. So all the computation are much faster in this way in respect to the other distribution function. And then the step 2 is the designing of the reference LCA model. And this is very, very classical approach for life cycle assessment. So we just model every phase of this reference geothermal system, and for example, so therefore, after the modeling, the life cycle modeling performed in compliance with the geothermal guidelines developed within Geoenvi, the next step is the identification of every background processes. For example, we can search for aluminum in this way, find tech act. So this is the word we need to use. We can search for aluminum inside the background database and so on. So here I just running this cell to search for these particular processes, and you can see here aluminum. I used this to search for aluminum, and this is the output. So I found in the Geoenvi database this aluminum, this process that which represent the production of aluminum. And again, same for all the process I need. Then the next step is the definition of the parameters. For example, in this case, the Bagnore power plant, which is used as a reference geothermal system, the length of the well is defined as a parameter. And in this case, we have the minimum depth is 586 meters to 4,070 and 27 meters. So this is the range related to the depth of the well. The distribution type, as I said, is linear. So every value between the minimum and the maximum has the same probability to be, let's say, computed, so to be calculated. And the unit of measure is meters, of course. And here I defined all the parameters I need. So the length of the well, the abutment ratio, so the performance of the abutment power plant, the wells number, so the number of the wells used in this case from 4 to 26 wells, the electric capacity, so from 20 megawatt to 120 megawatt, and so on. And just the list of all the parameters which we are able to identify for these reference case studies, and also for the natural direct environmental emissions, so the fraction of the non-condensable gases from a minimum to a maximum value. And in this case, also the fraction of the relative composition of these non-condensable gases, and for CO2, for CO, for methane, hydrogen sulfide, ammonia, and so on. And also we can print a table with all the parameters we choose. And you can see here we have a lot in this model is built using more than there are 27 parameters. So at the end, now we need 27 let's say input voices to be able to run to obtain a life cycle assessment results. At the end, the simplified models will only need very few parameters. So this is the reason why they are called these are called the simplified models, because we just need very few information to obtain a good life cycle assessment results. Then the model is also built on the basis of different equations which relate some characteristic of the model itself. And some of this comes from a project performed by Brina and Vito, which found this relationship for geothermal power plants. So, for example, the volume of the cement is related to the meters drilled for every wells with this mathematical relation. The energy for drilling the same, and the mass of the steel used. And also there are other kind of relationship that are found empirically. And for example, the electricity production is of course really in relation with the average load for the steam turbine. It's related to the electric capacity and to the energy of the auxiliaries need. So minus this portion, and then for the operating hours on yearly based operating hours. So these are all the function used in the model, and these are of course just to show you how the model is the complexity of the model itself. And I'm in this cell, I just stored all of these relationship inside Brightway. Then the definition of the model itself. So this process is very similar to the steps performed in OpenLCA. So we are going to define, for example, the well drilling process, and we need the bentonite, Portland steel, the drilling coming out from the drilling processes, the waste coming out from the drilling processes, and sodium hydroxide, water, and so on. So we define every input voice, so the inventory needed for the well drilling. And this is performed in, of course, using this code, new activity. This is the function used, implemented in the life cycle in LCA algebraic. Then I just run this section, and Brightway now know how to build the well drilling, and also in this case the well pad. So the well pad itself, so the Portland around the wellhead. And this is done for every process of the reference geothermal system. So the abutment system, the gas intercooler, the gas compressor, condenser. And so every component of the geothermal power plant is modeled in this way. So for example, the turbine, the 20 megawatt turbine is modeled in with the chromium steel. The electric generator, the pipelines, the building. And now executing this cell, Brightway know how to compute the life cycle assessment for all of these processes. And of course, you can see here the emissions of ammonia, CO2, H2S, SO2, and so on. Then the process this process is the one which include all the phases, so the commissioning, maintenance, use phase, the emission, and also in this case we also have a few production of heat for industrial purposes. And with this definition, we state that heat is an avoided product. So producing heat with the binary, with this reference geothermal system, we avoid to burn, in this case, natural gas to produce heat for industrial purposes. Then the next step is the statistical one, used to identify the key input parameters, which is this is a very complex procedure which is called global sensitivity analysis, and using a large number of iteration. Now I just see you the output with 100 iteration, but are too few to. Sorry, I need to define the impact list. Yeah, this is one of the reasons why the implementation of this kind of approach is quite difficult, because there are a lot of issues that can happen, and is needed also some knowledges in Python. So for example, using this command, it's possible to obtain some statistical information for the climate change impact category and the acidification potential impact category. So this Byron graph is representative of the statistical distribution of all the results coming out from the global sensitivity analysis. So from here you can see the index, but from value near to 0 to reach more than 8 kilograms of CO2 equivalent, with the average value of 0.8 kilogram of CO2 equivalent. And also we have also much more statistical information. So the quartile range, yes, the standard deviation, and this index, which is the SOBOL. This index is the most important for for our purposes, since thanks to this index it's possible to identify which parameters is important to be included in order to have the simplified model. So practically what we will can understand from this table is that the parameters describing the electric power can explain 35% of the whole variance of the our model, and the same for the climate change impact category, but also for the acidification potential impact category. So at the end, thanks to this SOBOL index, we can say that the installed electric power, the flow rate of geothermal fluid, the mass fraction of the non-condensable gases are very important. And at the end, in fact, these are the most important parameters, key input parameters we will see in our simplified models. As I said, 100 iteration to build these results are too few to have reliable results, and in fact are needed a very large number of iteration. And at the end, this is I performed this before this training seminar, but at the end the results is very similar. And again, we have the electric power, the flow rate of geothermal fluid, the mass fraction of the non-condensable gases, and for the acidification potential category we also have the fraction, the relative fraction of the hydrogen sulfide. So now we have identified the key input parameters needs to be included in our simplified models. And then we can now generate our simplified model. I use the normal way to generate these models is this one, so SOBOL simplified model and with this definition. But this definition, this is not working in this particular case due to a bug related to our libraries. So I need to select manually the parameters I want to be included in a simplified model. So with this the definition, I can say that I want the electric capacity, the fraction of the non-countable gases and the flow rate to be included in these simplified models. So in the simplified model for the climate change category, and I do the same for the acidification potential. But in the acidification potential, I also include the hydrogen sulfide fraction. Just run this cell and the output is very simple, the simplified models. So these are the simplified model for the climate change and the acidification potential. So as you can see, it's just a mathematical equation, and substituting these terms, you can obtain the life cycle assessment results for the climate change and the acidification potential for this particular reference geothermal system. We can also perform a comparison between the reference geothermal system, so the non-simplified model and the simplified model with these commands, and the output of this is the R square, so the level of the goodness of fitting of our simplified model, which is this orange one. It's quite good overlapping the blue one, which is the the detailed model with the R square of 0.9, so very good fitting for climate change, and quite similar for acidification potential, which also have higher R square parameter. So we can say that these simplified models are good, and because the results are very overlapping, so we can state that these simplified models are good, and we can proceed implementing these simplified models and using these simplified models. And therefore, after all of these very complex steps, and I know that quite annoying procedure, we can end up with a list of simplified model for every impact category. It's very important to stress the fact that these simplified models do not replace canonical LCA analysis, and developed following the Geoenvi guidelines. So it's very important to use the Geoenvi guidelines to perform a life cycle assessment for geothermal power plant. And also is very important to stress the fact that these simplified models can only be applied for specific kind of geothermal plant. In this case, for this reference geothermal system, since these models is built on the binary 3 and 4, these models can be used only for geothermal power plant that let's say are flash power plant, exploiting high enthalpy geothermal source, and having a specific range of electric capacity, flow rate, and fraction of non-condensable gases. All of these characteristics define the applicability domain, and you can find all of this information in the output of the Geoenvi project, which is the web platform, which include the simplified models for all the for 4 reference geothermal system. And now I'm going to show you also what we have done in for the web platform implementation. So you can see here, this is the web platform we developed for these purposes. And you can see here the 4 categories used to describe. Try to zoom in. So 4 categories. So an AGS power plant with downhole pump, so it's not a self-flowing kind of power plant, used to deliver industrial heat for industrial purposes. And since this is an EGS power plant, it make use of hydraulic and thermal stimulation of the geothermal results. So we can have, and this is based on the Rittershofen power plant located in France. Then we have the flash category, which is the one I show you now. And of course, this is the final energy use is electricity and industrial heat. This is a flash power plant, as I said, with the abatement system for the non-condensable gases, in particular for the hydrogen sulfide and mercury emission. And this is a flash plant. You can see here applicability domain. This is a flash plant or a dry steam power plant exploiting high enthalpy fields with the low to high content of non-condensable gases. And of course, you can see here also the case studies used to build this reference simplified model. So this case, Bagnore. And again, we have for the CHP, so heat and power geothermal power plant, which is based on the Hellisheidi power plant located in Iceland. Again, this is a single or double flash system with the power ranging from 200 to 15 megawatt and 50% of thermal capacity factor. So these are the characteristics that, for example, if you want to check the life cycle assessment results for a particular geothermal power plant, you need to compare the information you have with this table to identify which is the case you can use to perform the life cycle assessment computation. I just show you, for example, the case of the flash. You see here, every tab corresponds to a case, to a reference case. And for the flash, we developed this kind of interface. And the functional unit is, of course, 1 kilowatt hour of electricity produced. You can put here the name of your project, and the yellow cell is meant to be your input. So, for example, if I want to model I want to obtain a life cycle assessment result for a flash power plant, I need to use this sheet, so the flash sheet. And these are the information I need to fill in to obtain results compliant with all these impact categories. But for example, if I'm only interested in climate change, I only need to fill in the electrical capacity, the flow rate, and the fraction of the non-condensable gases. And so just, for example, if I have, I don't know, the maximum, the Bagnore value for the fraction of non-condensable gases, so 7% in mass. I have 60 megawatt of electric power installed. and a flow rate of 400 tons. For example, using these few parameters, I'm able to obtain a life cycle assessment results for the climate change impact category. And you can see the results here.
Nicola, we can't hear you.
Since we used value for binary, we obtained the same results, 100%. And all of this is the same for every impact category. And you can also have in table 5 the percentage, the numerical output of used to build this graph. So your value is the characterized results for every impact category, and then also the comparison against the reference model and the simplified model. So thank you for your attention. I know that it's quite a difficult topic, so because the background is very different from a usual person involved in geothermal sector due to the Python coding and so on. But I hope to give you a good perspective of what we have done in the Geoenvi framework and the efforts we done to develop these simplified models to give you the possibility to check by yourself life cycle assessment results. And I think that you will receive I don't know if you already have the link to this web page, but I think you will receive this by Dario Bonciani soon. I will contact him to be sure about that. So thank you for your attention.
Teşekkür ederiz Nikola. Oldukça detaylı ve teknik bir sunum oldu. Katılımcılarımızın gözü korktu gibi geldi bana ama tabii biz Nikola ve Lorenzo hem yaşam döngüsü değerlendirmesi hem de bu basitleştirilmiş model kısmında oldukça detaylı bir çalışma yaptılar bu proje kapsamında. Sonuçta burada biraz önce Nikola'nın da gösterdiği 4 ülkeye ait örnek vaka üzerinde basitleştirilmiş model türetildi. Burada tabii ki katılımcılardan beklediğimiz rızaları doğrultusunda beklediğimiz şey sadece hali hazırda bir web tabanlı platform oluşturuldu ve bu en son kısımda Nikola'nın da sunduğu o web bazlı platformdaki değerlerin kendi projeleri için doldurulması ve ondan sonra da bu sonuçların bizimle proje kapsamında gizlilik çerçevesinde paylaşılması. Bunun için Jester sizinle bir hem bu sunumların Türkçelerini, yapılan sunumların bugün Türkçelerini paylaşacak, hem de bir taahhütname paylaşacak. Rızanız olduğu takdirde bu projeye katkı koymak için kendi projelerinizin değerlerini, bu biraz daha sonra önümüzdeki günlerde henüz ulaşmadı son hali. Önümüzdeki günlerde size iletilecek olan web tabanlı platformdaki değerleri doldurmanızı rica ediyoruz sizden. Bu konuda Niyazi Hocam'ın söylemek istediği bir şey var mıdır? Eklemek istediği?
Evet, ben öncelikle bir şey sormak istiyorum Nikola'ya. Şimdi örneğin bu tanıtımı yapılan 4 proje içerisinde diyelim ki Dora 2'yi temsilen ben katılmış olsam bu projeye, bu en son verilen modelde, en son verilen web tabanlı modelde Dora 2'yi bunlardan hangisine yerleştirmem gerekiyor? Benim yerimde olsa nasıl bir şey yapardı?
Yeah, well, it's a good question indeed, because it's at the moment we do not have a place for Dora 2 power plant. So as you have seen, there is the possibility to a power plant which represents the Dora 2, so organic Rankine cycle for electricity production. So this is something that is missing. I'm sorry for that. I am not responsible to delivering and the planning this part of the project, but it's probably something that should be addressed in the future, I suppose, since it's a quite representative power plant. And from my point of view, maybe indeed, it's very hard to find a location for Dora 2 in this case. And yeah, I cannot say anything more. I'm very sorry about that. So at the end, we do not have a place for Dora 2 now.
Peki. Şimdi bizim şurada bu projede şöyle bir sıkıntımız var. Buraya davet ettiğimiz projedeki bizim projemize katkı koymak isteyen katılımcıların tamamı Dora 2'ye benzer santral işletmecileri ve onların temsilcilerinden yer oluşuyor. Şimdi böyle bir sıkıntı olacak. Yani burada bu sıkıntıyı nasıl aşacaklar? Belki soruyu tekrarlamış gibi oluyorum ama burada bu Geoenvi projesine katkı koyabilmek için uğraşan arkadaşlar bir sıkıntıya düşecek. Bu modellerden veya bu modellerin içerisinden karışık diyelim ki sondaj kısmını falan yerden, işletme kısmını, elektrik üretim kısmını falan projeden çekebilirsiniz gibisinden bir karışık bir sonuç çıkabilecek mi? Yoksa bu yani sonuçta Türkiye'den beklenen katkı çok da olmayabilir bu durumda.
Again, you are perfectly right, indeed. But I will pass these from other person involved in these tasks to find out if there is the possibility to overcome this issue. Lorenzo, if you want to add something.
Yes. Yeah, it's like Nicola said. I would like to say that the French partner was basically responsible for the simplified model development, as we were in charge as CSGI of developing the LCA model. So basically what we did was, okay, we don't have expertise in different countries to perform LCA. We will do the LCA like basically we did for Dora 2. But in the case of simplified model, they basically just went on with those countries that could do the simplified model. So yeah, I know that's basically you miss your simplified model, but that's not up to us. What we can do, probably we could ask, I'm not even an expert, but I think that at this point, a lot of, let's say, work has been already done, and it may be, and I'm asking also Nicola, not that difficult just to modify the already done models to fit basically DORA 2 power plant. And this could something that you should ask to the French partner, if that's an option. Basically include one tab more in the Excel web-based platform for DORA 2. But yeah, I'm asking also Nicola, because I'm not an expert on Python.
Of course, it is indeed possible, and I'm just imagining that it's possible to use the same reference model of Bagnore. So translating the flash power plant, so the equipment from a flash part to an organic ranking cycle equipment, since Bagnore and Elishadi are the only two kind of power plant that exploit high enthalpy geothermal source with content of non-condensable gases. So I think that indeed is it possible.
But again, if you're really interested in this, then you should, let's say, raise your voice to the French partner, because I also think it is indeed missing a very important, let's say, technology from the web-based. I agree with you on this. But yeah, you should really ask them, how can we solve this? And if we are asked to do additional work, then we can also do that. Or they can also do that, because they have the ability to do that. But basically only Nicola and Melanie could do the simplified model, and we were already overloaded with work in this project. And yeah, but again, you should ask the French partner to overcome this issue, I think.
French partner'dan kastın Armin mi, Lorenzo?
Yes.
Okay.
Yes.
Ya, Melanie mi sorumlu Armin'den?
Well, it's Blanc, Isabel Blanc, officially, but I think you can easily ask Melanie, because she has taken all the work from the past 2 years, basically.
Biz bunu daha önce birkaç kere dile getirdik. Özellikle Niyazi Hoca'yla. Fransız proje ortaklarımıza. Ancak tabii her projede olduğu gibi zaman ve finansal kısıtlar olduğu cevabı geldi. Birkaç kere bunu hem genel toplantılarımızda hem de özel toplantılarda dile getirdik. Neticede böyle bir şey olmadığı için tabii ki bu kimsenin sorumluluğunda değil. Ama Türkiye'nin, yani günün sonunda böyle bir eğitim semineri düzenledikten sonra katılımcılarımız da kendi gönüllülük esasına dayanarak değerli vakitlerini ayırarak o platformdaki verileri dolduracaklar ve bunu bizim projemizle paylaşacaklar. Bu projede sadece bunu doldurmak önemli olmamalı, bir işe yaraması gerektiğini düşünüyorum ben. Dolayısıyla oradaki 4 örnek vakanın sadece değerlerini doldurup orada bir rakam görmenin amacımız olmadığını düşünüyorum projede. Dolayısıyla bu doğrultuda eğer en azından DORA 2'ye benzer bir proje için basitleştirilmiş modelin hangisine daha uygun olacağı ya da Niyazi Hocam'ın da belirttiği gibi karışım bir model oluşturulabilir mi? Sadece sizin hani toplantılarda da bu yönde bir en azından fikir beyan etmeniz için bunu herhalde Niyazi Hocam söyledi. Sonuçta biz katılımcılarımıza bir yol göstereceğiz bunun eğitimin sonunda. Diyeceğiz ki şunu doldurun, bunu doldurun ya da bu sonuçlarda eğer takıldıkları noktada da sizlerden yine yardım isteyeceğiz. Ama günün sonunda bir değer elde edildiğinde, oradaki tablo değerleri elde edildiğinde bunun bir şey ifade etmesi gerekiyor. Ve eğer o parametreler tesis parametrelerine uymazsa bu durumda bunun pek bir anlamı olmuyor projede paylaşılması açısından. Umarım yanlış düşünmüyorumdur. Biz burada bu fikrimizi dile getirirken yanlış anlamayın. Kesinlikle size bu sorumluluğu yüklemiyoruz. Bu projede birlikteyiz ve sadece bir yol arayışındayız. Neticede burada gönüllülük esasıyla katılan katılımcılarımız var ve onların da vakitlerinden çalmak istemiyoruz. Bu konuda ne düşünürsünüz bilmiyorum tabii.
Yeah. I completely agree with you. I completely agree with you. Yeah, the point is that right now there is no way to basically check there is no simplified model right now for the DORA, and there is no way to get a simplified model unless more work is done, probably starting from the already available simplified models, and this is something that can be done. But yeah, right now the platform is not including the DORA type, and yeah, I'm sorry about that, but.
Niyazi Hocam, Ufuk Bey, sizin söylemek istediğiniz, katkı koymak istediğiniz bir şey var mı?
Çok teşekkür ederiz emekleri için herkese. Bizim söyleyeceğimiz bir şey yok. Buradan aldığımız derslerle yolumuza devam edeceğiz.
Katılımcılarımızdan soru var mıdır?
Ben bir şey sorabilir miyim Özge Hanım?
Tabii, buyurun.
Merhaba, ben Cannur Bozkurt. Ben İlker Bey'e sormak istiyorum. İlker Bey aramızda sanıyorum bakanlık ya da devleti diyelim temsilen katılan Enerji İşleri Genel Müdürlüğü'nden tek katılımcı. Ne düşünüyorsunuz model hakkında? Enerji işleri bunun hani model olarak yapılması, uygulanması konusunda pilot santral seçmek ister mi? Ya da nasıl destekler? Size sıcak geliyor mu o model yaklaşım? Uygulanabilirliği konusunda hani belki bir yönetmelik kapsamında hayata geçirilmesi konusunda düşünceleriniz nelerdir? Teşekkür ederim.
Canlı Hanım sanırım soruyu basitleştirilmiş modelin yaşam döngüsü analiziyle etkilerinin analiz edilmesi anlamında sordunuz.
Genel olarak aslında hani bunun bir gelmesi, bölgedeki jeotermal tepkiyi azaltması açısından ve basite indirgenmesi, yaygınlaştırılması için.
Okay, so
şöyle söyleyeyim. Yaşam döngüsü analizleri aslında bize jeotermal santrallerin etkilerini değerlendirmek konusunda çok değerli bilgiler veriyor. Şöyle bir husus var, hani basitleştirilmiş modelin dipnotlarında da o da belirtiliyordu. Bu hiçbir zaman gerçek bir yaşam döngüsü analizinin yerini tutmaz. Ama olasılık oranlarından gidersek, hatta Niyazi Hocam'ın dediği gibi Türkiye'deki santralleri simüle edecek, onlara yakınsayabilecek bir örnek de modellenebilirse, yaklaşımsal olarak modellenebilirse en azından ne yaptığımızı bilmek, hani emisyonlarımızı, etkilerimizi kontrol etmek, görmek açısından iyi olacağı kanaatindeyim. Bunun hani modele eklenmesi, bizim mevzuatımıza eklenmesi gibi hususlardan bahsettiniz. Onlar biraz daha Çevre Bakanlığı'nın alanına giriyor ama Çevre Bakanlığı'nın bu konuyu da çok böyle nasıl diyeyim mevzuatı kapsamında ele alacağını düşünmüyorum. Yalnız tabii ki hani bugün tartıştığımız olsun, o emisyon etkileri olsun, özellikle de bölge emisyonlarını dikkate alalım dediğimiz durumda bunların özellikle bizim Doğu 2 santrali gibi bizim santrallerimizi simüle edecek santraller üzerinden gidersek bizim için değerli veriler sağlayacaktır. Özellikle bazı tepkilerin ilk aşamada yönetilmesini çok daha etkin bir şekilde sağlayacaktır. O yönden çok önemli olduğunu düşünüyorum. Ama sanırım Niyazi Hocam'ın dediği gibi de bizim verilerle ilgili bir modelin güncellenmesi ve olasılık katsayılarının da hani daha doğrusu doğruluk katsayılarının gözden geçirilmesi gerekecek.
Teşekkür ederim İlker
Bunun
Bey.
dışında eklememi istediğiniz bir şey var mı? Hani bana sormak istediğiniz.
Benim için açıklayıcı. Ben kendi adıma teşekkür ederim.
Ben
Evet, katılımcılarımızdan başka yorum yapmak isteyen, soru sormak isteyen, projedeki basitleştirilmiş modelle ilgili olsun.
Merhabalar, Çağatay Mitil, MTN Enerji. Rahatlayabiliyor mu herkes?
Evet, evet, duyuyoruz.
Biz de Çanakkale'de bir binary santral işletiyoruz ORC sistemde. İki kuyudan kuyu içi pompa yardımıyla üretim yapıyoruz ve buhar fazında bir üretimimiz yok. Separasyonsuz çalışıyoruz. Dora 2 ile bu basitleştirilmiş modelin uyumsuzluğu konusundan bahsedilirken hani bizim de sanki projemizde çok uyumlu değil gibi görünüyor yapı itibarıyla. Geliştirilmeler yapılırken hani kayda geçmesi açısından bizim gibi sistemlerin de dikkate alınmasını rica edebilirsek eğer.
Yes, I can answer that. Of course, when a simplified model will be built, taking into consideration the technological aspect of Dora 2, then all the other power plants that are similar to Dora 2 can be, let's say, used in these simplified models. So you can every power plant that is similar to Dora 2 are able to be modeled using the same simplified model. So again, I can do an example of, so if we will use the data for the inventory of Dora 2 to build another simplified model for Dora 2 based simplified model, so a reference geothermal system which is similar to Dora 2, then this reference geothermal system is able to describe a wider set of geothermal power plant similar to Dora 2. So even if there are a lot of differences in terms of, for example, the power, or for example, the kind of, I don't know, the drilling, and there are some key parameters that are needed to be, let's say, fitted. So, for example, for the binary case study, from 500 meters to 5,000 meters of well length can be modeled with the same simplified model. So it's quite a wide range for these parameters. So at the end, if we are able to build a simplified model using the Dora 2 reference geothermal system, then all the other power plants similar to Dora 2 can be for sure modeled using the simplified model. I don't know if I answered the question. I'm sorry if I can't.
Nikola'nın cevabını yeterli buldunuz mu?
Tam olarak olmasa da teşekkür ederim. Yani modelin geliştirilmesi lazım. Hem ısıtma kısmının olmaması, hem separasyonun olmaması ve bu sebepten dolayı zaten Dora 2 ile benzerlik göstermeyen bir proje. Hani bizim de kullanabileceğimiz bir hale getirilebilirse bu basitleştirilmiş model, biz de bir parçası olmaktan memnuniyet duyarız.
Şimdi bir handikapı var tabii bu basitleştirilmiş modelin. İlk önce bizim seçtiğimiz örnek vakaların bir yaşam döngüsü değerlendirilmesi yapılması gerekiyor. Ondan sonra ona benzer projelerin basitleştirilmiş modelleri türetiliyor. Dolayısıyla eğer zaten yanlış söylüyorsam beni düzeltin hocam, Niyazi hocam. Herhalde Türkiye'deki jeotermal enerji santrallerinde yaşam döngüsü analizi olan bir tek Dora 2 projesi oldu şu anda. Benim bildiğim kadarıyla, bilmiyorum.
Doğru söylüyorsun. Evet.
Dolayısıyla ön koşul olarak bir tam teşekküllü bir yaşam döngüsü analizi değerlendirmesi olmayan projeler bu basitleştirilmiş modelle de uyarlanamıyor. Nikola'nın da demek istediği, diyor ki Dora 2 biz eğer oluşturursak, öyle bir basitleştirilmiş model ileride oluşturulursa ancak ona benzer bir santralde uygulanabilir, kullanılabilir. Çünkü zaten yaşam döngüsü değerlendirmesi birbirinden çok farklı olan ve onu baz alarak dizayn edilmiş bir model öbürüne de uygunluk göstermeyecektir dedi, yanlış anlamadıysam. Bu doğrultuda belki ilerleyen dönemlerde de sizin katkılarınızı değerlendirip tekrar yeni bir yol haritası çizilebilir Çağatay.
Çok teşekkür ederim.
Ben bir soru sorabilir miyim acaba?
Sorry.
Buyurun.
Ben bir soru sorabilir miyim? Acaba basitleştirilmiş modeli, prosesi parça parça ele alsak ve onlar için bir basitleştirilmiş model ortaya çıkarsaydık ve atıyorum Dora projesini atıyorum, tabii ki organik ranking cycle'ların çalışılması gerekirdi ama en azından jeotermal akışkanın ağzı, santralde enerjiye dönüştürülmesi, ısının kullanım, ne kadarının kullanılacağı şekilde santrali belli bir parçalara bölerek yapsaydık, hepsi için ayrı basitleştirilmiş modeli bulup ondan sonra bütüne gitseydik, acaba doğrulama yaparken elbette bir sapma olacaktı ama bize nasıl diyeyim, ileriki farklı santrallerde uygulanabilirliği için bir altyapı sunmaz mıydı? Hani bu konudan biraz uzak olarak söylüyorum. Hani anlayabildiğim kadarıyla soruyorum ama mümkün müydü böyle bir yaklaşım?
Nikola, cevap vermek ister misiniz?
Yeah, please. First, I want to say a few words about the previous question. So it's not when we build a simplified model, we only need one life cycle assessment model, so the reference geothermal system. The other power plants that can be, let's say, that have similarities with the reference geothermal system, we do not need to have the complete life cycle assessment model. We just need to know the key parameters that we chose and we identified. So this is the power of the simplified model itself. So we need just one reference LCA model, and then for other power plants we just need very few key parameters. So very few information. So not the whole life cycle model for similar power plant similar to Dora 2. And again, during the development of the reference geothermal system for simplified model, we can also choose to, let's say, use very wide technological description, for example. So we can use Boolean parameters to model the simplified model if for heat production or electricity production. So it's a very flexible tool. And so I don't know if I give you a little bit better description of what you have done and what is possible to do with simplified model. So we just need one reference LCA, and then for similar power plant, we just need very few parameters, very few parameters, very few information. And for the second question. And what about what you mean fragmentation? I think it's quite similar to the previous one. It's possible to keep in mind the flexibility of the tool and the fact that we develop a reference geothermal system as we want. So the parameters we will use, we define the parameters we will use. We can model a very wide set of geothermal systems. So I did not really get the question about the fragmentation. But in general, if a reference geothermal system is modeled in a way which is wide enough to describe a lot of geothermal system, then just few information are needed from a provider to obtain a good life cycle assessment result. Maybe I missed the question, but I really did not understand what its meaning for the meaning for fragmentation in this case.
Açıklık getirebilir miyim? Aslında fragment, yani parçalamaktan şunu kastettim. Yanlış anlamadıysam eğer verilerden. Jeotermal santrallerin, tesislerin emisyonları ile ilgili bütün çerçeveye baktığımızda aslında bir akışkandan kaynaklı, akışkan ve jeolojik formasyonun santrale yansıması, enerji üretimine yansıması kaynaklı emisyonların oluşturduğu bir çerçeve var. Bir de santralin tabii ki kendi yaşam döngüsü analizinden ortaya çıkan şeyler var, impact'ler var. Benim acaba jeotermal akışkan ağzının santrale kadar olan ağzı ayrı bir simplified model olarak alsaydık etkilerini, o kısmı kendi içerisinde bir model geliştirseydik, santralleri ayrı ayrı analiz etseydik, aralarında daha sonradan ilişki kursaydık, ilerlemek daha hızlı olabilir miydi veya mümkün olabilir miydi anlamında sordum sorumu.
No, I think it's not really useful since the system boundary for a reference geothermal system need to be defined a priori. So when we build the simplified model, we define it exact system boundary, and then we model everything connected with the environmental performance of the geothermal system. So it's not possible to use this kind of fragmentation. The model needs to be consolidated.
Okay.
Başka katılımı olan, katkısı olan, sorusu olan katılımcımız var mıdır? Evet. Başka soru ya da katkı yoksa Niyazi Hocam, Ufuk Bey, sonlandırabilir miyiz bu eğitim seminerimizi?
Evet.
Bizim her şey güzel. Sonlandırabiliriz. Herkesin eline sağlık. Hocamın diyeceği bir şey yoksa bence de sonlandıralım.
Ben de Nicola ve Lorenzo'ya bir şey hatırlatmak istiyorum son olarak. Şimdi bizim bu projemizin amacı uzman olmayan kişilerin de kolayca LCA yapabilmeleriydi parametrik model sayesinde. Şu anda Türkiye'de olduğu gibi dünyada da yapılan jeotermal santrallerin çok çok büyük bir kısmı DORA 2 benzeri santraller ve bu nedenle hatta Avrupa'da yapılanlar da böyle. Şu anda parametrik modeli için seçtiklerimizin büyük bir önemli bir kısmı zaten bu modellerin çoğuna uymuyor. Burada bir eksikliğimiz var. Bunu bir şekilde proje içinde tamamlayabilirsek ki Fransızların yapmasını istedi onu. Bu önemli bir katkı sağlayacak. Hem projemize de katkı sağlayacak hem de daha iyi bir şey yapmış olacağız. Ben hem Nicola'ya hem Lorenzo'ya katkılar için çok teşekkür ediyorum. Benim başka soracak ve ilave edecek bir şeyim yok. Çok teşekkür ederim.
Ben de tekrar teşekkür ediyorum. Hazırladıkları sunumlar, sundukları sunumlar için çok teşekkürler. Katılımcılarımıza da çok teşekkür ediyoruz katıldıkları için, değerli vakitlerini ayırdıkları için. Bugün içerisinde size daha önce belirttiğim gibi sunumların Türkçesi ve taahhütname gönderilecek. Arzu ettiğiniz takdirde bu belgeleri doldurup bize ulaştırabilirsiniz jestler aracılığıyla. Çok mutlu oluruz. İlerleyen günlerde eğer böyle bir basitleştirilmiş modele karar verilirse tekrar sizi haberdar ederiz ve bu doğrultuda yol gösterildiğinde iş paketi lideri tarafından hangi örnek vakaya uygun olursa o vakayı kullanarak verilerinizi sizden rica ederiz. Katılımınız için çok teşekkür ederiz. Eğitim seminerini o zaman burada sonlandırıyoruz. Başka toplantılarda görüşmek dileğiyle.
Özge Hocam çok özür dilerim. Ben şimdi eğitime katılan tüm meslektaşlarımıza belirttiğiniz taahhütnameyi ve Türkçe sunumları gönderdim. Fakat bu taahhütnamenin imzalanması için belirli bir süre var mıdır? Bu konuda da bilgi verebilirsek.
Yani tabii proje kapsamında olabildiğince çabuk isteniyor. Yani bir haftalık süre içerisinde ne yazık ki antetli kağıda basılmasını ve imzalanmasını istiyorlar. Tabii pandemi sürecinde bunun iletilmesi biraz zor olacak ama tarayıcıyla ya da fotoğraf şeklinde gönderebilirlerse çok memnun oluruz. Çünkü bu bizim ayrıca şey olarak sunulacak. Yani bir çıktı olarak, proje çıktısı olarak sunuluyor. Bu belgeler şey yapılıyor, dosyalanıyor. O yüzden böyle bir şey rica edeceğiz kendilerinden. Bir süre yok tabii ki, net bir süre, ama bir hafta içerisinde olursa ben de sisteme yükleyeceğim sonra onu. Çünkü bir eğitim seminerinin çıktısı olarak bunu yapmamız gerekiyor. Evet Seda Hanım, herhalde başka bir şey yok.
Evet, teşekkür ederim. Sağ olun.
Eğitim seminerini sonlandırıyoruz. Katılımlarınız için çok teşekkür ederiz. Herkese iyi günler diliyoruz.
Sağlıkla kalın. Görüşürüz.
Teşekkürler, iyi çalışmalar.
Goodbye.
Teşekkürler.
Thank you. Thank you. Goodbye.
Thank you. Bye.
Teşekkür ederiz herkese. Çok sağ olun.
Hoşça kalın. İyi günler.